All right, let's start over. I didn't have the microphone on, so that's the thing. Can you guys hear me now? It should be on now. All right. Hi everyone, it's Nono here, and what I was saying is that this is live stream number 8. We've been looking at many different things, and today we're gonna take a look at different topics. We're gonna see some new technologies we haven't seen yet and get to do hands-on coding. So just to get started, I will remind you this is part of the machine learning series. This is live number 8, not 7 as the slide says. And I would recommend you to like the video if this is the type of content that you want to watch, and to subscribe if you want to get notified for future live streams and videos. And also, we have some people here on the chat, and there is some people also on the Discord channel, on the Discord server. So I'll invite you to join the community so we can chat over the week, and we can maybe propose topics for the live series, for tutorials, or maybe share your projects or talk about the technologies that you're using or you would like to learn about. All right, live number 7 was last week, so that was November 19th. We went through the second part of image classification. This was building a custom classifier to recognize images on the Fashion MNIST dataset. It was a really simple network that only had 3 layers, and we recorded a few tutorials there as well that are already released. And we also did some part of getting simple live. So we answered, we did a QA session live, and I responded one of the questions of one of our listeners that will be released soon on the podcast. All right. I have, as I promised, I've uploaded the separate videos from previous live streams. So what I try to do is to record tutorials and then edit them to be a bit shorter and more clear on my laptop, and then upload them to YouTube as separate videos. So these all are available now on the YouTube channel. And now, okay, so I have a few ideas. So, there's things that I want to do over the next weeks, like looking more at Lowe, at Runway, looking at training custom algorithms in SageMaker, reiterating some of the tutorials that we've done before, using maybe SketchINN, classification networks, object detection networks, and look at many things that we want to know or want to learn about. All right. One thing, okay, so before I continue, let's just wait for a second here. So I see that there's people connecting, so I see that the audio is good now. I would love to hear from you on the chat. If you are connecting and you haven't connected before, or you've connected before, just say hi. Just write maybe why you found the channel or what you're looking to learn on this channel, and also maybe who you are and where you're connecting from. All right, so where were we? A few things that we're gonna see are just bits and pieces of, I'm just trying to skip through this, and pieces of technology. So we have ML5, P5.js, we have TensorFlow and TensorFlow.js, we have TensorFlow Hub, and we have Keras, and we have some other things that we're gonna take a look at. So if we start with ML5, or maybe we take a look quickly at some of the things that I wanted to do today. I think we're gonna have time to cover at least training a custom TensorFlow model in SageMaker. This is something that I've been looking at to automate some of my workflows, and we're gonna try to do that with the model that we've been coding in live number 6 and line number 7. And PyTorch is something as well that I'm starting to take a look at as well. Is another another machine learning library that is more oriented toward research, but they're starting to also have light versions that allow you to port more efficient models to Android and iOS. I would like to record that training custom TensorFlow model in SageMaker as a tutorial, and maybe re-record the custom Python environments. This was creating Python environments with Anaconda in a way that is a bit faster and might be a bit more digestible than an 11-minute video as we have at the moment. These are things maybe for future days, not for today's, and also I have Keras applications. But we're gonna see more and more things. All right. I can see here on the chat, hello from Vermont. So Jose Luis García Castillo is connecting from Vermont. I'm a bit jealous after seeing some of your pictures, I have to say. Pedro Cortés is connecting again. Hi, from Barcelona. And Sujay is connecting from India. And Mayur is connecting from Illinois, I believe. So Bea and Lourdes are connecting from Malaga. All right. Thanks so much for joining. Feel free to write any comments that you have on the chat along the live stream. And yeah, so let's get started. So first, I'm just going to introduce you to a few frameworks that exist there for machine learning that try to make machine learning a bit more accessible, or at least allow us to deploy models in more places. Like ML5 or TensorFlow.js allow us to port models in a format that can be consumed in a browser tab. So you could be running machine learning models and doing things in your own website. Yeah, hello to Sora and Barbara as well. So, so what is ML5, right? So that's the first thing we're gonna take a look at. So ML5, if you go to ml5js.org, is an open source project that offers friendly machine learning for the web. This is, I would say, one of the easiest entry points for you to get started with machine learning, at least using models that other people have trained and prepared. And they even have demos online. So let me just make this a bit bigger. Let's see where they have these demos. So yeah, the APIs, or the way that you would make use of this, is fairly simple. You would just load ML5 and get an image classifier, and then pass images to it to classify them. In this case, if we quickly just take a look at this code here, what ML5 does is instantiate a classifier, then tell us on the console that the model is being loaded, and then we can classify an image by passing just an element that contains, so this is a DOM element, so this would be a website element that you will be able to pass to the model to classify. Yeah, so Mayur is mentioning here that the coding train has good tutorials on ML5.js. So the coding train, for those who don't know about it, is Daniel Schiffman's channel. So he's got like 1.2 million subscribers here, and he has a ton of tutorials and live streams and little videos on how to use ML5 and also create websites with it, or do things like this to even use it with OBS and your webcam. So I will encourage you to go there. I'm just introducing it here as well to get to do some things and get to use some of our models with TensorFlow.js and ML5. And if you go to GitHub, I think that some of the main contributors to ML5 are Daniel Schiffman and Cristobal Valenzuela, other people like Joy Lee and Jining Shi. I don't know. There are many contributors as you can see here. But yeah, so this initiative is a really open initiative, and you can probably collaborate, and is as you can see here, is heavily related to processing and its web analog that is P5.js. All right, where were we? So I'm not going to code at the moment with this. We'll see later or another day if we actually get hands-on with this. But the good thing is you can go here, find one of these models, and either see a demo or find examples on how you can add them to your own applications. So as I mentioned before, this is by Jining Shi, and just with 4 or 5 lines of code, you can load a trained model and use it to on your images. In this case, to generate images with your own web app. There, let's just make a quick look here. So there's like neural networks, feature structure, nearest neighbors classifiers, k-means algorithms, image classifier, postnet, body pics. There's a lot of stuff, and we can come back. And SketchNN, that I know Major really wants to get doing things with this. All right, what else do we have? So we're not gonna code at the moment with this. So we have P5.js. P5.js, I can go to my own site. So I made this app here that is a broken WebSocket collaboration drawing board. And there are many other things that I've done. It's just a library to make interactive applications where you can draw and you can interact, you can do many things. So in this case, I think this might slow down my machine, so I'm just gonna close this one. And what is P5.js? Again, p5js.org, and it's a JavaScript library for creative coding. If you know Daniel Schiffman, you know this library, so probably not something new for you, but it's really easy to start going with P5.js and doing things on the web, either to display animations or also to create interactive apps. This application that I built with Nate Peters for a workshop that we gave with Jose Luis García Castillo is an interactive board, but it's not using P5. It's something that is fairly similar in concept, at least for the drawing side, not so much for the rest of the interaction paradigms. This is another JavaScript library that you can use to create interactive applications. So that's Paper.js. All right, TensorFlow.js. So TensorFlow.js at tensorflow.org/js is a library for machine learning in JavaScript. So you can do many things of the things that you can do in normal TensorFlow with Python in JavaScript. You can create neural networks, you can train them, you can load models, you can save models, you can predict, you can generate images, you can do many things. And the good thing is that they always provide existing models, so pre-trained models that you can either use or start training your own models with them, and also to develop with their APIs. Also here, tensorflow.org/js, and this is, as I said, just a lot of different networks that you can either do your own or use some of the ones that exist. So if you go and see the models, we could, for instance, get a JavaScript mobile net version where we could just load that model and quickly start classifying and displaying the predictions or doing something with them. The API here is really similar to ML5.js, but ML5.js goes one step beyond and actually, makes it even easier. So yeah, this would be a good thing to, compare them. What is the difference between ML5.js and TensorFlow.js, which I didn't mention. So ML5.js is a wrapper around TensorFlow.js. And here there is a, okay, there is a, let me see. So one thing, let me just switch on the audio so you can hear the videos I play.
A new playlist of videos. This is a playlist. I mean, you know, hopefully there's a bunch of videos in this playlist.
All right. So this is Daniel Schiffman explaining what ML5 is and what you can do with it. So we'll put that link on the chat. And I'll close this one. But yeah, I mean, you can see the code that we saw before is fairly similar. So you have to load a few JavaScript dependencies, as you have to do here. And then you just grab a, well, what is this? Yeah. So you can get some idea there, right? The only thing is that once you load ML5, the instantiating the classify and classifying is a bit less verbose, so you don't have to be dealing with like promises and things like that. But you know, it's fairly similar. Okay, so let's keep going. So we're gonna use some of these models hopefully later. And I also wanted to introduce TensorFlow Hub. TensorFlow Hub is a repository, as I mentioned before, trained machine learning models. They're available in TensorFlow version, so that's like normal TensorFlow core, TensorFlow Lite, and also TensorFlow.js. Not all of them are available in all formats, but you know, they're really good to start trying. And even with this API, with the TensorFlow Hub package in Python, you can directly get models as a Keras layer, which allows you to either use the model directly or use them as a layer in another model. So, right, you can, when you create a TensorFlow model, for instance, with Keras, you can add a set of layers, one after the other, to form your model. But then that model becomes one custom layer that you can append to other models, or you can use to add layers before or after. Okay, and then there is Keras, but let's just open the TensorFlow Hub before we go to Keras, and just take a look at the models that we have here. Similar to what we saw before, but a bit more general. So if we go, for instance, to image, there's a ton of tags. We can see image classification, and we can get state-of-the-art models already trained for us. So if we say, for instance, here, inception, we can get either the feature vector model or the classification model. So inception v3, we can go here, as you can see, we have the TF version and then JavaScript version for this one. And you know, we could, for many models, if they're not using custom operations or weird functions, we could download them and convert them to different formats. So we can get a TensorFlow core model, load them as a model, and then export as TF Lite or export as TensorFlow.js. And I keep talking about TensorFlow Lite, and I haven't mentioned what it is. So it's a more efficient version that only has like a minimal runtime, the minimum things that TensorFlow needs to run or execute a model. And it's the most efficient to run on embedded devices like Android, iOS, and you know, and more devices that are supporting these architectures. All right, so let's see what else we have here. So you can see here, this is what I was. Let me make this a bit bigger. All right, so what we can see here is what we did last week. So we built a tf.keras.sequential model that had layer after layer. And what you can see there is that we're using this hub.keras layer as the only layer in our model. And then when we build it, we specify the input size, right? That's 299 RGB channels, and none means that we can input a batch. So this is something that I would like to try today. So let's just copy this part here. Let's see if we can just copy and paste to our slideshow. Right. Okay, so we'll come back to this as well. And then Keras. So I want to show you, well, Keras.io. So if you go to Keras.io, we also got yet another library for machine learning. This is something we've already been using in previous live streams. It's an abstraction or a layer that allows you to have, first, an easier way to use or to build machine learning models and train them. And second, a way to, like, to standardize an API that can work on top of TensorFlow, PyTorch, and other types of machine learning libraries. And what I wanted to show today are the the Keras applications. So API of Keras is really, really big. We've only seen the sequential model API. But here you can see this extensive list of models that are state-of-the-art machine learning models. Most of them are, or I would say all of them here are classification models. And what you can see here is the top 1, top 5 accuracy. This is the benchmark, right? Like how well it categorizes the top 5 categories on each image. All right, and from here what you can do is that you could download these ones, but you can also just use them with code, as we do with the TensorFlow Hub. So we could, let's just see what this code sample is doing. And I'm also gonna copy here to my slides. All right. So in this example here, what we can see is a code that allows you to go from loading the required libraries in TensorFlow Keras to loading that model with a specific weight, and also then to load an image that we have on disk, converting that image to an array, and then passing that image through the network in a way that it can classify it and give us predictions. And we're gonna see that later as well. All right, what do we have here? Okay, so and this we're gonna record, and yeah, let's start coding. All right, so I introduced many of the things that we might see today, and now what I'm gonna do is start coding. So we're gonna start recording, and let's see what we can make. Okay, before we get to code, is there anything specific that you would like to see today? Right, let me make a brief pause. All right, I'm back. What are we gonna do now? I'm gonna go and re-record one of the tutorials that we already have. I don't know if you've seen it, but I've tried to rewatch it and it seems a bit slow. It seems like a bit slow for somebody who just wants to get the job done. So I'm just trying to do that, to re-record some of the tutorials that are useful, but a bit too slow for people to actually get value out of them. So let's make this as our cover here. And let me get in here. Oh, maybe there. All right. So what do we need for this tutorial? We definitely don't need this part here, or this, or this, or this. We might need this later. Whoops. What's going on here? Okay, that works. All right. Okay, so let me see. So let's see if this actually makes it a bit more understandable. So we have here these two slides. So this is the process of what we're going to go through. So this is just a simple set of steps that you need to do in order to be able to create a custom Anaconda Python environment for you to be able to code with specific versions of Python and TensorFlow in your machine. And you can have multiple of them, right? So let's see, let's recap on what we have to see in this tutorial. So we got to see that what this is. So this is about making custom environments where you can code in Python. This is about installing libraries that you need. In this case, we're going to do two different versions of TensorFlow. And we're going to name those in a way that it shows up on our kernel notebooks or Jupyter notebooks. All right, so we'll start with this and we're going to see which ones we have already. Okay. Hi everyone, it's Nono here. We're now gonna see how to create custom Python node. We're gonna see how to create custom Python environments using Anaconda. So you can have different versions of TensorFlow in this case or other Python packages installed in a sandboxed environment. If all you want is just to know the code that you need, you can just follow these lines. And with those 5 steps, you'll be able to have that installed on your machine. But we're gonna do it step by step. So the first thing you'll do is go into, as you can see here, conda create, then the name of our environment. So we're gonna say tf new 2.3.1, and we're going to specify the Python version and IPyKernel. IPyKernel is specifically important because if you don't do it, then you won't have a custom Python version inside of this environment and later on your Jupyter Notebook kernel. So we're gonna put here Python 3.8 and then IPyKernel. This is going to install our dependencies in that sandboxed or environment of Anaconda. We're gonna say yes, and then this is going to run on the background to gather all those packages in a way that can be executed only affecting that environment. After we do this, we have to enter the environment and then expose that kernel as a kernel that can be seen by Jupyter. And then later we have to expose those, and then later we have to expose this environment as something that your Jupyter notebooks can see. And then afterwards, we'll install custom packages for you to see that this actually works. All right, so this is already working now, so we can do conda activate tf new 2.3.1. Now we're inside of our environment, and we're gonna run this command to expose our kernel on Jupyter notebooks. So Python, we can do here which Python to see that we're using the right Python. So we'll use Python 3, you can see it here. So we'll do Python 3, model IPyKernel, install for this user with the name tf new 2.3. I don't really know what name I use now. All right, so let's see, what did I create there? tf new 2.3.1. So we're gonna verify it. So we're gonna verify that the Python version that we're using is the one in our newly created environment, and now we're going to use that to call our IPyKernel package to install for our user with the new environment tf new dash 2.3.1, and then we're going to specify the display name to be TensorFlow new 2.3.1. All right, so that's now exposed in Jupyter, so we can run Jupyter Lab when this runs, and this will execute Jupyter Lab and open a notebook in which we can select this kernel and work with the dependency packages that are inside of that new kernel. All right, so then we'll have to pip install TensorFlow to be able to have those dependencies working on our notebook. All right, this is still a bit too long, so let's just try here. So we have our Jupyter Lab. All right, so we can see our TensorFlow new 2.3.1, and if we run a console, we'll be able to use this environment, but we need to actually install. So say pip install TensorFlow and then install the latest version of TensorFlow. All right, let me actually just do that once again because this has been a bit slow. Okay. Okay, we'll maybe Maybe I will. All right, so let me see. Hi, it's Nono here. We're now going to see how to create a custom Python environment using Anaconda. So you can encapsulate the packages that you need to use for specific things in different environments. You can just use these 5 lines of code in your terminal if you just want to get going, but I'm going to explain what each of these ones does. All right, so first thing is that we use Conda to create our new environment. So new TF 2.3.1, for instance, and we make sure to select the Python version that we want, and also to mention that we want ipykernel installed there. This is going to gather all the dependency packages that you need to have on your environment. We're going to say yes, and then it will install them and even give you a specific version of Python 3, in this case that Python 3.8 installation, so you can install other packages and use this environment even in your Jupyter labs. So we can go and copy this text here. So conda activate new TF 2.3.1, we can install, for instance, a custom package like TensorFlow. This is going to actually select the currently latest version, that is TensorFlow 2.3.1. And then later we'll have to do this here. So we'll have to activate that kernel to be visible to our Jupyter lab notebooks, and that way we'll be able to use it. So if we go and use that command directly, we can, this is installing TensorFlow still. We can run on a separate notebook. We can activate our new TF 2.3.1 environment. We can call Jupyter Lab. And in a separate window that we had here, we already have TensorFlow installed. And we can actually see which version of Python is being used. So we'll use this Python 3 version with ipykernel to install for the current user the new TF 2.3.1 kernel with this plain name new TensorFlow 2.3.1 kernel. We run this command, and this is going to actually just expose it in our Jupyter notebooks. And what we're going to see is that after we do that on our launcher, apart from these ones here that I've created, we'll have that new TensorFlow 2.3.1, right? So you see there's like 6 here, and if I update now, you can see there is a new one that is probably this one, new TensorFlow 2.3.1, and if I select it, you're gonna see that this is the environment that we want to be working on. All right, so let's start a new notebook with that kernel. So you can see it's new TensorFlow 2.3.1, and then if we now import TensorFlow as TF and then print the TensorFlow version, we should get that this is version 2.3.1. You can create custom environments with different versions of TensorFlow, like TensorFlow 2.2.0, 1.14, whatever you need for different projects, and you can have them in your computer at the same time. You can go to this drop down and select the different kernels here, and use different versions interchangeably at different times in your day. All right, let's see if this actually returns. I think that was a bit more fluid, and yeah. Right, it's me. when you go, let me see, where am I? Here. And then in Jupyter Lab, you can create a new notebook with this new TensorFlow 2.3.1 kernel, and we can actually just take a look at what version of TensorFlow is loading. You can see that it's loading 2.3.1 correctly. And if we open a new one with this TensorFlow 2.2.1 and run the same command, this environment should have the TensorFlow 2.2.1 version installed. Yeah. All right. And these were the summary commands that I've been using in this tutorial. And in this way, you can create separate environments using Anaconda to run different Python libraries and different packages for different needs and different projects. Thanks a lot for watching, and I'll see you next time. All right. Okay, so that's one thing. I think that might be a bit shorter than what I had before. So we've done this part here. Okay, so now we're gonna see something that is a bit more useful. So I've been playing a bit with SageMaker to see what you can do with the notebooks there. Is similar to Colab, but they also have a lot of infrastructure like Google Cloud Platform in order to be able to train and deploy and do hyperparameter tuning and many other things that are good for machine learning. All right, so SageMaker, let's see where this is. Okay, so I'm gonna talk briefly about what SageMaker is. SageMaker is the bed of Amazon Web Services, AWS, to offer Jupyter notebooks, algorithms. So to offer Jupyter notebooks and also a way to manage your models, deploy them, train them, and do other things like data labeling and hyperparameter tuning, right? So SageMaker is the part of AWS that is dedicated to machine learning. The one thing that I'm going to talk about right now is how to train custom TensorFlow models inside of SageMaker. And the highlight that I have is that while you can, let's say, rent or use a really cheap notebook inside of SageMaker with a CPU reserved for you for 4 cents an hour, you can go for like a normal GPU that you can use in Colab or something. You can go up to 3.8 or even 6, or there are machines that are $30 an hour. In this case, the cheap option that I have here, there is a ton of options in SageMaker, is 84 times cheaper than the other alternative, right? So what are we going to look at? We're going to look at how to get the model that we were training last week. That was the fashion MNIST dataset image classifier that was classifying 28 by 28 pixel images. We're going to try to train that on a machine that is just going to train. So it's a machine that's going to start up with a Docker image, and it's going to train on the cloud and then save our model to a specific location. So the model that we've seen repeatedly here by now is this model that has these 3 layers. It's just a trivial model. We could get a model from TensorFlow Hub, we can write another one, whatever, but it's just a TensorFlow model that is a sequential Keras model with 3 layers. So there is a way in which you can convert this code or the code that we have in this notebook for SageMaker. So it trains your model in a notebook in the cloud. All right, let's close a few things here. And okay. So let me see if I can open here. Maybe. Hello, Chandra. Nice to see you online. All right, so in-service notebooks. All right, so here I'm gonna open a list of the notebooks that I have active right now. So this is one of those 4 cents an hour notebooks, and it's running in SageMaker, and I called it ML Training SageMaker. The instance type is MLT2 medium. So if we go to SageMaker notebook pricing, we're going to be able to see many different options, many different tiers of pricing that we can use. So for notebooks, so for studio notebooks, this is actually SageMaker Studio. I don't know if it's the same that notebooks, on-demand notebook instances. Yeah. So these are the prices I believe that I'm using at the moment. So MLT2 medium. So this is the price I had before. So it's 4 cents, 0.6 an hour. But as I mentioned before, if we go to the MLP3 2x large, it's like 3.8, and you can get to this 8x large and 16x large and get to really high prices really quickly by the hour. How do you avoid the fact that, you know, if you open a notebook, the money is running, right? So right now, this notebook here is in service. So for every second or every minute that is open, it's going to be charging my account. If it's 4 cents an hour, it's not that of a big deal. But if it's $3, $16, $8, $30, that starts adding up really quickly. And if you go to sleep and you forget about it, you can accrue really big bills really quickly. The thing here is that even though you can use one of those expensive or more expensive instances to have it open and to be developing and then running things with a GPU reserved for you, and it's good for debugging when you really need it, you can use one of the cheap instances and then make or call a training job that is going to use one of those expensive instances, but just for the time that you need for training. You know, if the training goes well, you'll just be paying for the seconds where the machine is starting up, that as I saw this morning with the instance I was running was like 60 seconds or so, and then the time that your algorithm is actually running. You can see here let me see if I can make this bigger so you can see. So you can see here many runs that I did to try training this model before, and we have 4-minute runs, 3-minute runs that I stopped. This one completed. Some of them failed, some of them ran. You can see the errors here where it failed, and you can get a sense here if I go and say, okay, how much time did this run and how much am I being billed? So this is like 124 seconds billed. And you can see the instance type that you were using. So here is an ML P2X large in this case, right? So there are many technical names here, but I don't intend you to remember any of this or anything. This is just to let you know that on the web, right, on your machine, you just have a laptop, whatever that laptop comes with, or the drivers or the GPU, the CPU, that's what you got. So it doesn't matter. So you're just using the CPU of your laptop. If you're lucky and you have a GPU that you can use with TensorFlow or with these models, these libraries, you can plug to it, and that's what you got, unless you buy an external GPU, an eGPU, and then connect it to work with TensorFlow. But on the cloud, we can actually be developing with any laptop or any hardware or anything, and then on the cloud, either on Colab or on SageMaker, we can pay to use CPUs or to use GPUs, right? So in this case, I was using the MLP2X large, and one thing I noticed this morning is the training image. So this is the image that you actually use for training on an EC2 machine, right? So let's scroll back a bit and try to understand all the concepts. So EC2 is the Elastic Compute Cloud of Amazon. So it is like a place where you would host a website. So you're renting a machine that is on for the time that you have it on. You can have it on for 24 hours or a month and host a website, host files or whatever, and it's running there. So in this case, what we're doing is that we're renting one of those machines for the time that our algorithm is training, and we are switching it off and not paying anymore when our algorithm either is stopped, fails, or completes, right? In this case, the image that I was using, and these are images that we're going to see now. There's a big list with different specifications. In this case, this is the region where it was. This is that is in Amazon. Sorry, I was in the middle of the URL. So this is the region, AWS URL. This means that we're using TensorFlow, that we're using it for training. The version of TensorFlow, CPU is whether we're using the CPU or GPU device. Pi37 is Python 3.7, and then the operating system. In this case, I actually was using CPU, which I shouldn't have because these models with TensorFlow can automatically catch the GPU, and that's something we're going to try right now. So we're just going to make a quick exercise here and see if this works. So I've opened my, this notebook that I have here, and I'm going to stop for a second. We have a quick question here on the chat. Can you train multiple models at the same time? And if you can, does it charge you for each runtime separately? Yeah, it does, Sajid. It does charge separately for each instance or each training job that you launch. You can launch as many jobs as you want at the same time. They have many machines, and they are willing to be, to charge you for whatever you need or whatever you want to use. You could. Well, there are two different things. One is you could use multiple instances to train different models. And then the other alternative is that you can use multiple instances with just one job to do distributed training. That is when you can actually, when your algorithm is set up in a way that it can use many different machines to train different parts of your algorithm and then train faster. All right, so let's continue. So we've seen that this is a notebook that is on. I've clicked on Open Jupyter Lab, so I have this this notebook open. This is on the cloud. You can see the URL here. So it's an open notebook that I'm accessing to online, and we have here. So I already set up this code here that I'm gonna make bigger. Otherwise, you're not gonna be able to see. I already set up this example so we can take a look at, and we don't do all the hands-on coding at the moment. So this is training a custom TensorFlow model in SageMaker. I was looking for this many places, and it wasn't really clear how to do it in this way. There were examples, but it was hard for me to actually understand how to swap my own model there or my own code and do that training, right? Yeah, you're welcome, Suje. So the thing here is that we have available Docker images and then also the documentation. So the available Docker images are a list of pre-made Docker image URLs that we can use directly to train our algorithms. And if we go here to TensorFlow, so we can build them like this. We can build, we could change TensorFlow over PyTorch, change the version number in here, and we can do many things, many changes there. All right. So what I got, and let me see if any of this has GPU, right? So you can see here, I got the wrong one actually. So this is a version with GPU that you can see has probably the CUDA version, so maybe 10.2. And this other one just has a CPU, right? So what I did before, I tried different training runs, but I wanna try more just to see if the GPU makes a difference. So we're gonna copy this URL here, and we're gonna change it on our algorithm. So we're gonna put here CPU and now here GPU, image URI, and I guess that this is small still to see, right? Can you see anything? Well, can you read it now? Okay, so this would be our image URI. And I'm gonna comment here, and we're gonna parameterize this URI as well. So here we're gonna use the region from the current session. So Amazon can provide that to the notebook automatically, and we don't have to code that by hand. We're using TensorFlow training 2.3.1, GPU, CUDA is required. Those are the drivers that are required for the algorithm to run, and that should work. So let's see if we can do it with this image. So we have both the CPU and GPU, and the one thing I can do here, so I've put a hyperparameter here. I'm just gonna put the epochs to 1, so this is really fast, and I'm just gonna go ahead and run everything. So run all cells. I'll explain what this is doing as we go. Let me just make a bit of space here. All right, so the cell in the top is actually just importing. So we don't really have to import TensorFlow here because we're just importing the SageMaker library to be able to create something that is called a TensorFlow estimator. So it's like a wrapper around. It's like a helper function that allows to call a training job or a deployment job in SageMaker. And when we do this part here, what we're actually obtaining are the role and the region. So this is the role, the execution role inside of AWS. It's like the permissions that allow you to actually call a training job. That's something that's going to cost you money. And then the region. The region is something that we have to use in this case here because it always works faster. I don't really know if you can even do it with different regions, but if you provide the region that the notebook is running, the EC2 is running for that Docker image, everything's going to happen more like rapidly. Sometimes you cannot access AWS's 3 buckets. Those are like remote folders, storage folders, if they're in different regions, for instance. So it's good to have them all in the same region. So we make sure that this works. So up here, we're getting the role and the region. And below here, so we set up the estimator. So the estimator has some function parameters. So we have the entry point. This is the Python custom model algorithm that we have prepared. And this has a specific syntax that we gotta use. We specify the role, the instance count. So this is what I was mentioning before about distributed training. So if our model supports distributed training, we could specify here 1, 2, 3, like how many instances we can our algorithm can train with. Instance type, this is what I mentioned before as well. So we could put here MLT2 medium or other ones, or P to 3x large, P3 2x large. We could put different instance types here to train. So different prices, different GPU, different speeds. And then we have the image URI. This is what I mentioned before. This is a Docker image. So for those of you who don't know what Docker is, it's yet another technology. It's a containerization tool. So this allows you to put the entire environment, including the operating system of like an environment or a container. So you specify the operating system, the libraries that have to be installed, the dependencies and everything. And then just with that Docker definition file, you can reproduce that machine and recreate a virtual machine anywhere. You can start a new machine that has everything that your algorithm needs to run. In this case, what we have is that we have a machine that is going to have all these things listed here. So it's going to have Python 3.7, it's going to have a CPU, it's going to have TensorFlow for training 2.3.1, it's going to have Ubuntu 18.04 as the operating system, many things. And later, just by changing this URI, we could have our custom one. If we want to pack custom dependencies, we could create our custom Docker image and then upload it somewhere, and then have this machine from AWS to like download it and build a machine with that. And that avoids manual setups of the environment in which you're going to train in that EC2 instance. And then later we have the hyperparameters. So we specify what model Well, this is the directory where we want the model to be saved to. I haven't really figured this one out yet. So I'm gonna go ahead and actually remove this because this is not making any effect. And then script mode. There is some warning that the algorithm is giving me on every epoch. And if I put this to true, the difference is that script mode false. So this actually shouldn't print if I put script mode to false, but yeah, it seems like it is still. So what we can see here is that when we call estimator.fit, we're actually specifying one more thing, that is the directory where the data has to be downloaded from our custom Python algorithm. All right, many things, and we're not gonna see yet that custom code, so this fashion MNIST algorithm, so we're gonna see that Python file later. And what we're gonna take a look at now is what's being printed here. So we have the training has started, the ML instances, so that EC2 machine is being launched. Then we're preparing the instances for training. We're downloading the input data from this path here that I specified. And we're downloading the training image download complete, training in progress. And this is the training image for, the Docker image. And, after this happens, the training actually starts, and all this blue tells us the training environment. So here you can debug the variables that you've sent. Something that you can also do is print here your hyperparameters, so you can see the things that your TensorFlow estimator is assuming. So that, for instance, you can see here that the epoch is being passed. And later I put some custom, there's a lot of environment variables that get passed to, or arguments that get passed to this script. And then I put these two statements there. So loading fashion MNIST data, so this is from my custom Python file, and then training model for one epoch. If we scroll down, this is the annoying warning that I was seeing that I don't really know how to get rid of yet. It's just showing way too many times. And then afterwards, we can see that, the model is uploaded. So uploading generated training model to a specific folder, and then that the training job has completed. Training seconds 88, billable seconds 88. That means that we've paid for the price of that ML P2 X large instance, we've paid for 88 seconds. All right, let's kick off another job. And then later we'll be looking, while we do that, we'll be looking at some of the results of this run. So this is with GPU. And now I'm gonna try with GPU. So we're just gonna run exactly the same. So we're gonna clear all outputs on the cells. And we're gonna run exactly the same training with the GPU image. All right, so this is starting the training job also, so it's gonna be doing the same initial setup. And if we go to our training jobs, now we can see that we've started at 7 p.m. for me. We've started a new training job that has completed successfully in 4 minutes. So it said that the billable seconds were 88. So 88 actually is 1.5 minutes, but the job actually took 4 minutes. So we've only been billed for 88 seconds of those, because a lot of the time that the algorithm took to set up is things that don't really have anything to do with ourselves running, but with Amazon setting up the infrastructure that your algorithm needs to run on. And that's good. I mean, this is, we've paid, if we run that on another notebook using the GPU, we might only use those 88 seconds, but we will have some setup time. We'll have to fire the notebook. It will have to open. We'll have to click. We'll have to, we have to look at the data. We'll have to look that everything's working fine. And then we'll click on training. Then it will train, and then from the moment that the training has finished until we actually close the notebook, it might pass some time because we want to take a look at the model, we want to save it, we want to export it. With this, nothing of that happens. So you actually already have that model saved to S3 and the instance is switched off. So you're not paying anything else. And what we're gonna go now is to look at that folder. So we have the training output and the data. So I'm gonna show you the data that the algorithm is obtaining is in here. So it's a fashionmnis.npy. This is a NumPy SavedModel. And if we look at the TensorFlow output, we can see the output for the folders that with the artifacts of both of the folders that we've been using, right? So the first one, that is this one that we fired at 7 p.m. in my case, and here it says 6. It has the source. So the source is actually that Python file that we use for training, where we have set up our network, and the output, that is the model that was trained and then uploaded there, right? So we can download this and we can see it on our machine, right? So we can see that here is a TensorFlow core model with the checkpoint data here, right? Okay, so if we go to the other folder, so this is the one of the latest model with GPU, we can check here and we don't see any output here. I'm not sure why, but if we look into the training jobs, let's see if that has finished or not. Okay, in progress. So it actually says that it hasn't finished yet. I don't really know why, but the model is already here. 1209. That's interesting. Okay, so this seems like this is still busy and I don't really know what it's doing. But let's just take a look. So, and the problem here is that what I'm trying to do is that if we don't get a Docker image that has CUDA and GPU, we're going to be paying for an instance that has GPU without using the GPU. We're actually going to use the CPU of that machine either way. And, let's see again that matrix of pricing and see the GPU. So GPU, SageMaker, GPU, notebook, instances. All right, so that might not even have a GPU. So let's see. I remember there was another table that would list the GPUs. So no GPUs, 1 and more. So ML P3 2x large. All right, so we're gonna try to use this one just to make sure that we're using GPUs to train. So the loading training image. Yeah, this is taking super long to set up. Not sure why, but the model seems to already be there, which is really weird. All right. So, okay, yeah. So this actually, this was the right. Yeah. Okay, my bad. So this was actually the the job that I just trained, and this was one I trained this morning. So this is the latest one, and we should see the output. Yeah, the output folder is still not there because this hasn't finished, and it's going to start training now. So we can see that Keras is being loaded. So there seems like some GPU might be available. I don't know if we'll get any information here to see what devices we have available on this machine. Let's see, invoking. So you see, we're actually calling the fashion.mnis.py algorithm. So for one epoch, and the model there is this one that actually is not useful. And we're gonna train for one epoch, and then we get this this warning that I don't know how to get rid of yet. And billable seconds 160. Not sure why that happened. Not sure why this instance is actually taking longer. But what we should see here is the output model. So the output model is also 1.8 megs, and we're not gonna try again with the ML P3 2x large. All right, so we'll try once more. So same type of instance, and we're gonna run all cells once again. And I don't really know what this is for because this is not doing anything. We'll just leave it there for now. All right, run all cells. Okay, once more, let's see how long this takes to set up the instance. So it seems like it's been really varying, so we're changing a lot from instance to instance. So this one has taken 7 minutes, but I don't think it's been 7 minutes training, and this one has been 4 minutes. Let's see the differences. So in the one, yeah, we don't really get any more information about this. Like, it just tells us it's been there for let me see. Yeah, this would be cool. Maybe we can actually see the time that, like, how much GPU has been used on each of these algorithms. Not sure. Oh, okay. So memory utilization, CPU, GPU memory. Yeah, GPU memory is at 0. And then we have here CPU utilization 75. This is for the job that was training with the GPU. So no GPU, well, what I thought was with the GPU, but no GPU was being used, really. So we'll see on the latest one, we'll see what this actually does, and if it's actually using the GPU. That's what I would like to see. And then, if that happens, I would love to compare training for like longer, for like maybe 50 epochs or so, or 30 epochs, and see if there is a big difference between GPU and no GPU, or each type of instance. Because ideally, what you want to get is, you want to get faster, shorter times. So shorter times from training with GPU than training without GPU. And all right, so let me see, where were we? Let me just close a few things here. And that summary, what we said before, 84 times cheaper to use one of the normal notebooks than using one of the ones that have GPU. I didn't really know this, and I know that sometimes, well, I knew this, but I didn't know how to train on a separate machine only for that period of time. But I know it's really comfortable to use the GPU machines when you're doing development. So if you actually need to run many times the GPU to retrain and do tests, and you don't want to have to be like sending jobs, you just want to be debugging, it's useful to use the GPU instance for a couple hours. This is what Google Colab is for, actually. So you get the pro version, or even without the pro version, and you get a GPU on the backend for free, and you don't have to worry about it. You can use GPU and even TPU for distributed training. Right, let's close this part and see where we are. So we have still time, and this is downloading the image. So we have here the training jobs. We have our S3 bucket where models are being saved to. So we have this. This is for the latest model that we're training, and this is the data that is being used for training. And we have this notebook we're gonna close. Right, we've seen this, so we're like kind of wrapping up this part, and we've gone through some of these things. So this is done. All right, I would like to say hi to anyone who has connected since I last said this, and if you wanna write on the chat and let us know who you are, where you're connecting from, and where you're looking from to get out from these videos. All right, so this is the training notebook. So also loading Keras, we're loading the script. I haven't found any information before of whether this is something that has GPU or not, but maybe, I don't know, maybe there's a way that we could see this here, but I'm not seeing it right now. And then reporting train success. Boom. So after training finishes, we get the job completed and the model is already uploaded. So we now will get the output of how many minutes, how many seconds or minutes were being built. 126. Is that the same than before? Let's see. You know, one thing to note here is that even if we use the GPU, the setup time is important, because the algorithm, the training part is not that slow for just one epoch. For one epoch might be like 3 or 1 second, so there's not going to be a huge difference unless we fire many more epochs. So all right, in order, so this is the first one, 88 seconds, 160, 126. So with the one that has the GPU, we took more to train one epoch than the one that doesn't have it, and that might be because the instance and the environment takes shorter to set up. So if we don't have to install Keras and TensorFlow GPU, that process of installing the Python packages might be faster. So that's why we might be seeing that. But then from the same instance with GPU and what I think is without GPU or a slower GPU, we're actually starting to see a difference. So if we, you know, this is a PX, P2X, so let's see if we can actually visualize it this way. All right, so we have on the right, so this is the first, second, and third training run. If we scroll down, so same row for everything, and this image is CPU, this image is GPU, this image is GPU, and let's keep going. What we see, the difference on instance, so this is P2X large, and then this is P3X large. So this actually has a GPU, for sure. And then here, we probably won't be able to compare, but we can open it. We can zoom in here. So for the GPU one, do we actually use the GPU? Not too sure. When we probably have to wait some time to get reports here. So we were getting reports on the first machine. So we have here 0 GPU utilization and 57. And then on the second one, we're getting no data. Why are we not getting any data? No data, try time range. Okay, so we'll minutes. What is this? Minutes, 45 minutes. I don't really understand. Okay, so let's see GPU utilization. Yeah, I'm not sure. Don't know. I will have to see. But this doesn't look like great. Okay. Let's go back once more to our training algorithm. So now last test I'm gonna do. So I'm gonna run this on, let's say, yeah, the problem is, let me just take a look here. So if I can avoid all this logging here. So script mode, TensorFlow estimator. Script mode, please. For the training script to complete before returning. Wait. Okay, so can we do that? Can we? Okay, so we can, the false or true whether to show. Okay, so what I'm looking at here, run TensorBoard locally, job name, if not specified, generate default job name. All right, so let's try to see, so job name, well, let's try that. So let's see, so train, let's see if this works. Okay, so we can, maybe, I tried this, but this, I don't know if this works properly. So we put here training as our argument, and we're now gonna add more arguments. So we'll have here a, let's see, weight equals false, and then job name, fashion MNIST. All right, so we go here and say, okay, the date, import date time, and date time model is not Kyle. Each. All right, import from the input time delta from date time, import date. Okay, yeah, all right. Import date, and then we do date. Can we do this? All right. So I'm just trying to reconstruct what the algorithm is doing automatically. So I'm trying to just construct a date and append it to the name of our algorithm. So we're gonna have the date of now here, and we're gonna try to see if we can that way. HMS. Why doesn't this work? Date time now. All right. Okay, got it. So this is the dynamic variable with the date on timestamp of right now, and we're gonna just put this here. So we're gonna put here this and then format and that, just to test, does this work? Yep, all right. Okay, so we have our date here, so we're gonna make that so, and we're gonna try, so we're gonna see if this actually kicks off a training job. So this is, all our training jobs are here. This is our notebook. Oof, it's too small. Just do that. Okay, so we're gonna do once more, execute all cells, and what I expect to happen is the output not to show up there. So we're not gonna wait for this to finish here. We're just gonna launch the job and then we'll get done. And all right, so let's try to do that. So run all cells, and ideally, oh, error. Okay, expecting one of string, training input file cannot format input type. All right, so I guess I would have to just put a string here. Yuri input false must be valid S3 or must start with S3. Yeah, I had this problem before. I don't really know how to pass. So input, the S3 location, the S3 locations of the dataset takes one of two forms. An S3 URI, which indicates the dataset, a dictionary mapping channel names to S3 locations. Optional arguments, defaults to true, whether to block, whether to show logs produced by training job in the Python session, only meaningful when weight is true. How do we pass these optional arguments? Required and optional arguments. Okay, your input data, weight false. All right, I didn't see this. So I guess we'll just pass this here, and then we'll have all the other variables as arguments. Wait, false. All right, let's see. Run all cells. Fingers crossed. This is gonna work. Okay, so now you see this has returned. So we can do other things here and they get executed because we're not waiting for this to return. The thing that happens now is that we have detached ourselves from this estimator, and we could reattach to it if we wanted. So we could attach, right? So we can, if we have the training job, we can attach to it. So we can say, okay, I have my name here, and I could say estimator attach training job name, and then we can say here this, right? And then we attach to it, and then we're receiving, right? We're receiving the logs of what we actually didn't want to see, but we reattach to it. With this, I want to show that, you know, now we're attached, and our entire notebook, so this entire notebook here is frozen. So it's executing in here. This means that we're actually executing, and that doesn't let us use it. We cannot fire more jobs, as Suje mentioned before. So we can fire more machines to train in different ways. If we don't do it this way, we could actually set up different estimators and launch them all at the same time and actually see which ones end earlier. And that would be actually a good exercise to do. And I think that's what we're gonna try. So this is running here now, and what we're gonna do is that afterwards we're gonna detach from this. So we're gonna stop looking, let's say, stop listening to what this cell has to say, and yeah, and we'll keep going. But if you look in here, the notebook is actually executing, and I'm not going to be able to execute anything until this returns, right? So when this returns means that the process of the other cell actually finished, and it's detached from that. But we can kill the notebook, and hopefully if we put our kernel back, so we put Conda TensorFlow 2, well, whatever, actually it doesn't really matter now, we might recover. Yeah, I don't know, this might not get back to us until this has finished, but we'll try it. All right, how's everyone going? Are you finding this useful? Are you not? Feel free to write any comments. Let me know what you're thinking so far. If you have any doubts, if you know what this could be used for, or if you don't, or if this is unclear, just let me know. All right, so last thing we're gonna do, we're just gonna fire many different machines to be training in parallel. As I mentioned, we're gonna call them, and we're gonna attach something meaningful to their names in a way that, you know, we can understand what's going on. Okay, Sajid, thanks for the feedback. All right, and you know, let's try to do something more visual in the second part of today's live stream. So we've gone almost for 2 hours now, I think. We're gonna make a little pause, and then we'll come back. Right, let's see when this returns. So we're still training for 1 epoch. And while this is training, I'm going to, let's see, well, maybe I can wait and I can get take a little break to drink some water when this actually returns something meaningful. Okay, so this was the other instance. Let's try to look at the training job that we did with GPU, see if there's anything here. Nope, no information. Oh, memory, GPU, so no GPU utilization. Why is this not using GPU? Okay, so while this is going, the one thing that happens here is that we haven't yet looked at the Python script that is being used. And you know, one thing we could do is that when we load TensorFlow, we could check whether the GPU is being used or not. So this is the algorithm. So it's probably a bit ugly to read in here, but this is what we are training. So we're loading TensorFlow. In this case, it's 2.3.1. That is what's being used on the instance. Then we're using argparse to parse this command line arguments that SageMaker is passing to it. This OS is just the operating system, NumPy, and JSON. When this program gets called, right, I print the args just to debug, and then I say, okay, we're loading the fashion MNIST dataset, and then we load the data, and then we say we're training for X amount of epochs, and then we train that classifier. We pass the data, the train data and labels, and the evaluation or test data and labels, and then the number of epochs. What happens when we call load data, so I simplified this by just saving everything that was initially downloaded from the TensorFlow dataset repository into that fashion MNIST and NumPy file that we're saving, like pickling or saving there in S3. And we're just loading that into data and then deconstructing that into train data, train labels, eval data, eval labels. And then the MNIST classifier, we're calling model with that. And then this model function, that is the function that gets to construct the model, we just create a sequential model. So we just create this sequential model with 4 layers. This is what we've seen over the past 2 live streams. We compile the model and then we train it. We fit and then we evaluate it. We didn't really need to evaluate the model here. We could remove this part if we're just training and just want to make it faster. And then we return the model. And there's not much more there. So there's this statement here that saves the model. I don't know if it's actually saving to H5 or just saving as a TensorFlow core model. But yeah, this is what we're using. And maybe what we can do is run some code to make sure that we're using the GPU inside of there. So TensorFlow Python client, import device lib. So let's just try to do this inside of our notebook or our algorithm here. All right. Okay. And we're gonna print this at the beginning. All right, so we save, and this is already updated on the other algorithm because this is what it's using. It seems like this hasn't returned yet, but this one says it's completed, so it should be fine. So complete in 5 minutes now, and let's see. So let's just try it. Let's just close this thing, close the runtime. Let's try to open again. Okay, this is working now. Okay, now you get the runtime back. Okay, so what I said, we're gonna manually, let's say, we're just gonna fire a few different jobs. So I'm going to MLT. So what was my chip instance there? All right, so MLT2 medium. So this is the really cheap one that just has a GPU. So we're gonna put that here. All right, so we're gonna use this one, and that's gonna be MLT2 medium. So for the name, okay, so okay, let's just put this here. So we are using that instance in a machine that has a GPU. And we're gonna do, let's just parameterize this a bit so we make sure that we name things properly. Epochs, let's say now we're gonna do 30. Instance type is gonna be MLT2 medium, and image URI Docker images, we have this one. And we have this one, so this is GPU. So CPU and GPU. All right, that works. So we're gonna use the image URI GPU. I'm gonna hard code this for just for naming purposes. So we're gonna put here, we're gonna remove that part. So we're gonna put here instance type, and we're gonna put here, oh, not that one. So that we put here, and then we put here as well the device. So the device in this case is CPU. CPU, ML2T medium, instance type, and image URI. We do here image URI, and then we put here epochs. All right, so we have this set up now in a way that we can quickly change variables. And what we're gonna do is, let's actually train, now that we're gonna test this, let's train 100 epochs in 3 different machines. The T2 medium, the ML P3 2x large, and the one, well, actually let's just do these two. So and we'll just do here replace dot with dash. Right. All right, so now we have a way to get our name automatically for the function. So we are going to fire 2 different jobs. One is going to be this one, and then another one is going to be this one. So we're going to move, let's just move this up above. We can use this date here. So we put the date here, so we can use it for other things. And yeah, this should be the CPU one. And I'm gonna run that. Let's just see if this works. We have 100 epochs, right? 100 epochs. Run all cells. Error. Cool. Algorithm specification, training image, valid. US West, CPU, Ubuntu training, CPU, class tuple. Okay, run all cells. All right, so once more, I just had a typo there, forgot a comma, and now another typo or what? An error occurred when calling creating training job operation. We specified mlt2.medium. mlt2.medium. Okay, yeah, so now we gotta go into SageMaker training instances. So for training, we actually don't have that mlt2, right? We have the p2x large. Right. So we're gonna use that p2x large. Then we'll use that one. Okay. All right, one more try. Let's see. Okay, so this works, and at the same time now, before we move too much, I don't know if that's GPU or not, but yeah, so device is CPU, so we're gonna use GPU now, and now actually let's do CPU as well, but we're gonna use the other one. So we're gonna fire another job with the CPU one for 100 epochs, and we're gonna run all cells, and that's done now. And now I'm gonna run the same thing, but everything with the GPU. So just to see if that makes any difference at all. All right, so that's fired. And now what we're gonna see, we have 3 jobs that are running at the same time. We have one, this is really nice now because we can see that we have 3 jobs. That one has the fashion MNIST P2 X large with the CPU. The second one is the P3 2X large, but with a CPU. And then the last one has a P3 2X large with the GPU. And what I would really want to see is if these two make any difference at all between execution times. And we would probably need like an algorithm that is a bit slower to train, because this is just like, it's a matter of 30 seconds total or 90 seconds total to train 30 epochs. But yeah, we'll see. So this might take like somewhere from 5 to 10 minutes. So I'm gonna take a really quick break, and we'll be back when this is trained. All right, so let me go for a second. See you in a bit. All right, we're back. How's everyone doing? Okay. Ooh. Almost back. All right. How's everyone going? So are you looking forward to seeing the results? So this is, we've left the models training in 3 different types of instances. So we have these 3 types of instances here that have the same data set, same model, but we're training with 3 different instance types that are different in price, and also 2 are using CPU and the other one is using a GPU. I'm not sure if we're gonna see impressive results, but let's see. Still going good. Okay. All right. Something weird might have happened here, but these things are still in progress. I don't really know what that means. I don't really know if that means that they haven't executed. Oh, they're still training. One thing that we can do is that we can attach to them. So right, we attached to the other instance before, and these are still training because we're training for 100 epochs and not for 1 like we were doing before. And my suspicion is that we're not actually taking advantage of the GPU, and that's something that I need to take a look at, and we'll probably see in the future when I probably figure it out. But what we can do on the meanwhile, now that we're not going to fire more instances, we can attach to this instance. So let's say P3 estimator, we can say TensorFlow attach, and then the instance name. I think this was the syntax that we were seeing before. I'm just gonna try it. Okay, yeah. So training image download complete, training in progress. And I don't really know if we'll get the log here, but probably not. Maybe we just get the training output to tell us when it's done, and that's it. So we'll just start getting dots here, I guess. We won't really get any more output for now. Okay, yeah, so that's training, which is good, and we can see here the training time, and that probably would be the amount of billable seconds. So we have been going for 8 minutes right now with this one, probably similar with the other ones, and they are all going to 100 epochs, right? That's what we set them to here. And we can only attach to 1 instance per notebook, but we could attach to all of them, and that's something I'm not going to do that right now. It's the same process. You just attach by putting here the name of the instance size training, and that's it, which is good. This means that we could, as I went, drink some water and take a break, you could just fire a few training jobs that you need, and you can cap the amount of maximum seconds that you want this to run. So in here there's like that's like 24 hours for to leave the machine running for an hour. So this is something that we could probably have taken care of. So we could say, okay, I don't want this machine to be able to run for longer than 30 minutes or longer than an hour, and then it will stop the machine when it goes over. But at least you know that you can cap your costs. If instead of 100 epochs you put 1000, that might run forever and never end. So the training job has completed. So that's like, I don't know, I would say maybe 9 or 10 minutes. We can go back here, and okay, that's a success. So at least the first thing that this does is that it's telling us that the GPU version that we've used, so this P3 2x large GPU version, is the one that has finished the first one. So it's taken 12 minutes. I don't really know how the others will be, but it's a good, it's a good hint to say, okay, I don't know if we're doing everything right, but at least we know that it has taken the shortest time to train and that the other ones are slower. One thing that we could do, the last experiment we could do is try to use one of those expensive instances in order to see if we can cut down the training time even longer. Okay, so we have here a question from Azure. Is there a major, sorry, let me just change my sites and let me zoom in here. Is there any, oh, I always do this. Let's put it here. Is there any major difference in services of Azure, AWS, Google Cloud Platform? What are your thoughts on Paperspace for cloud training? Well, I know that Cristobal Valenzuela, the co-founder of Runway, used to use Paperspace a lot. I don't know if they're still using it or if they are using AWS at the moment. I don't really know what cloud infrastructure Paperspace.io has. But what I know is that their system for training is easier to use, right? What they've done is, and they have now a free GPU plan with Gradient. They have, Gradient community notebooks, beta. Get started now. And, I would say their API is easier. It's easier to set up, and I would guess that they offer similar machines. I've tried it before, but I haven't really tried it too much. And I've tried it with local notebooks where you connect from your machine to a Gradient space. Let's see. Create your own preterm installer, enterprise pricing. Let me see, where is Gradient? Yeah, I'm not sure. I mean, I like their UI and the way that they display things and how they make it is a bit easier and a bit nicer. So Gradient Job Runner, get started. I remember having an account, but I don't really know right now. But yeah, Gradient seems good to me. Like I haven't yet compared them. I know that Google GCP, so Google Cloud Platform, seems like it's also a bit easier to use than AWS. But AWS, it just depends on what you are more familiar with and what you can use. Google Cloud Platform is also really compatible with TensorFlow X or TensorFlow Extended. And that also makes it really nice if you want to have an end-to-end workflow with machine learning workflow. I also like a lot the way that TensorFlow makes it really easy to deploy models and to version them and do that. And I haven't yet used the infrastructure in AWS to do that. It automatically uses TensorFlow serving to version and offer an API where you can not only access the latest model, but also access previous versions of a model fairly easily. And I haven't yet used Azure. I've heard good things, but I've never used it. And yeah, I don't know, maybe I'll use it in the future. I think they're all doing a really good job. All right, so 16 minutes for 2x large with CPU. I don't really know what that means. That might mean that we're actually not using the GPU properly, or maybe we are. Maybe that's the difference. Maybe you save, that's the time that you save. It's like 834 and 585, so it's like 70% of the time. Do we have GPU usage? Okay, finally, nice. this is what I wanted to see. So I'm glad that this worked, because that means that we've done something. So this is the GPU utilization and the CPU utilization. So here we have 150.95. I don't know what that means, but in the non-GPU one, so the CPU is actually being used a lot. You can see here, so up to 500 or something. And the GPU is at 0. So we're not using it at all. So you can see here this GPU utilization for the non-GPU machine and the GPU memory utilization. But the memory and the CPU of the machine, so that's the RAM and the disk utilization, they are active. And then for the version with GPU, we actually have a point here, and I don't really know how to make sense of this pointer here of 6.75. Let me see, 11, so 1851. So a bit after that, we get some GPU utilization, CPU utilization. I'm not sure what this means. I don't really know how much the actual training took. And that's something probably that we could have logged, and maybe that's already logged in CloudWatch. Yeah, thank you, Major. What is your take? What do you think? Have you used them? Are you familiar with Paperspace, Azure, Google Cloud Platform, and AWS? I'm open to hearing if you know more than I do in that sense. All right, so this, we have here the AWS Cloud Logs. We can actually see how long it took to train. If we can skip all these warnings that I don't understand why they happen. Okay, yeah, this is really annoying. Filter events. How can we filter minus warning? Can we do this? All right. Yeah, he's major mystery. I can unveil. Yeah. All right. So we can see here epoch by epoch on the GPU. So this is a CPU version, and then we have the, okay, nice. This is really small for you to see, but now a bit bigger. So this actually shows the GPU that is available for us here in this machine, and this is showing how long it's training. So it's taking to train each epoch. So each epoch is taking around 3 seconds. So that's like, well, 300 seconds, that is 5 minutes. And so 5 minutes to train and a long time to set up here. So 6 minutes to, so 56. Oh no, actually 56. Oh, so this is what we're getting charged. So we are doing that, and then minute number 3. Yeah, so I don't fully understand why we're getting charged for 546. That is 9 minutes. And we are getting here just, that goes from 56 till 03. That's like 8 minutes. I don't really understand it, but that's what's happening. Can we actually also maybe for next? Valid. All right, yeah, so we'll stick with that. So that is here, and then we get the other one. So it took 19 minutes with the P2X large, and then the P3 2X large, we might be able to see we might be able to see also the logs. Yeah, so Matthew is saying here that using Paperspace to train PyTorch 3D was super simple. So that's that's a good thing. This seems to be maybe something that is a bit harder. All right, so let's see. So here we have a different machine that, as you can see, doesn't have a GPU. So we can see that here, and TensorFlow is not recognizing any GPUs. The algorithm is taking around the same time to set up, so like 1 minute or less. Yeah, less than 1 minute in this machine that is CPU based. There is no GPUs to set, and then each epoch is taking 6 seconds, right? So 24, 32, 6 or 7 seconds per epoch, right? 6 or 7 seconds. So the training time goes up to 10 minutes. Well, actually double the time. So we're actually making the time half of that initial time on training. And the last thing I'm gonna do, if we just want to make a test, is train with one of those expensive instances for less epochs. We do less epochs, so it's gonna be, yeah, so let's do maybe maybe 10 epochs, and we'll use the ML maybe let's use this one. Yeah, let's use this instance here. So if that's gonna be, let's see, so we're taking, what is it, 509 minutes. How long did it take us to train? 12. We paid for 585. That's 10 minutes. So if we calculate 10 minutes, so 10, that was 63 cents. But if we train for that length with this one that is 28, that's gonna be $4. But if we train for less time, so it might take, it might take like 7 minutes or something, and we're taking less epochs. So, well, let's just take a look at how much that is and whether this is something, well, not really gonna do it right now, but that's something that we'll try in the future. So we'll change the epochs, we'll change the instance types, and we'll experiment just to see whether that is an increase in performance. Let's just actually try it. Okay, so we can try with this one, P3 16x large, and we'll put here 20 epochs, GPU, and run. All right. Oh no, don't attach to that one. Okay, yeah, so it doesn't matter because we've already finished. Okay, so we can actually attach to it now. So we can attach to it to know when it's finished and know that it's actually running. But yeah, that's our instance. It's nice. This is a good practice. So we've parameterized, as I said before, we parameterized the name of the training jobs, and that way, we don't only have the timestamp and the name of the algorithm that we're training, but also the instance type and whether we were using GPU or not. You can put more stuff there, you can look at stuff inside, but it's good to have a view from outside to know what the jobs are. With these ones, I had no real clue. I don't really know what they are or what configuration unless I go click open and then look at the nitty gritty. And I believe that, SageMaker, AWS doesn't let you rename anything, almost anything. Everything's written in stone with names and stuff, except for everything that's in S3. And you cannot really rename things. So it's really annoying, and you should probably have a thought before naming things. I don't even think that they let you remove these things. So if you take a look, I have training jobs here, and I don't think I can delete them, which, it's a bit weird. Okay, so we can then attach to this one just to be able to monitorize. And I'm gonna ask you guys, now that you're online, is there anything that, because we're gonna move away from AWS SageMaker right now, is there anything that you would like to see today? Anything that you would like me to try to cover or for us to try to do? I have a few ideas, but I just wanted to hear your opinion now that you're here, and see, what technologies or what things you would like for me to play with. We have maybe 1 hour, 1 hour and a half left. And also, I would like to ask what you got from this. Like, if you watched it, maybe leave a comment or put it on the chat. What did you get out of this? What do you think? Is it going to be useful? Do you think you understood some concepts from what I've explained? Just let me know. Okay, and as you can see, we've been running this notebook for the whole session, but that's compared to what we spent training. This is just for the 2 hours and a half we've gone. That's like what, 10 cents. It's not really money. So it really pays off to use these instance types for all the work that we're doing here in the remote notebook, and then leaving everything else for just the training parts. Okay, I'm gonna put this here. This is just a test format. So feel free to ask. If we have time, I'll answer some questions. That's what I'm here for as well. And this is the first one. As you can see, I really waste my time formatting things. All right, where is the chat? Okay, so let me try to see if I can do this well. So you guys tell me if you can hear me well now. I'm gonna go into podcast mode here, just with the mic. So Mayur asked if there's anything in my learning journey while learning machine learning that I wish I had done differently. And formatting saves a lot of time later. Yeah, that's true. So what things have I regretted. So the other day I was writing a bit to just tell a story in one of my posts about this. So I went to study in Cambridge. So I lived in Boston, Cambridge, specifically living in Cambridge for 3 years. So from 2015 to 2007, so 2018, so exactly August to August or something like that. And I had the chance to take some courses on artificial intelligence. So I took basic courses of artificial intelligence. We went through things like reinforcement learning, constraint satisfaction problems, decision trees, many things that I really enjoyed learning, and I think they have been useful. But one of my regrets, or one of the things that I would have done differently, is that I would have formally taken, instead of taking 2 artificial intelligence courses, I would have taken maybe those, or like swap one of those for a formal machine learning course. So I took artificial intelligence courses that is more like how all this evolved or how all this developed, but I didn't really take a formal course in machine learning. So concepts like convolutional networks and gradient descent. Well, gradient descent we saw, but things like optimizers, or the functions and the loss function, and all these things that you have to do to measure while you're training, and how they influence your models. That's something that I didn't really get to learn in a formal setting. Well, I had the opportunity to take formal computer science courses with some of the best professors, arguably, but that's something that I can also do now. So with books that I have here, with online resources, with videos, and arguably you might learn some of that as well with these videos that I'm trying to do live, to learn myself and to help you learn with me at the same time. So yeah, thanks for the question, Mayer, and yeah, feel free guys to put more questions on the chat. We might answer them today. All right. Did you have a vision while learning machine learning? How? Okay, so I'm gonna make a pause for this. So I'm gonna actually reply or answer these questions, because I think it's cool. Maybe we can even put this as separate videos. Also, guys, I wanted to ask: Are you guys? I'm looking for help, collaboration on the project. So I'm looking for people who can maybe help me out, think about the overall concept of this live stream and the contents that we see in the future. I'm also trying to prepare an application, something that I have in mind for to help people learn machine learning and machine learning concepts and artificial intelligence. And also I'm editing all the videos myself. I would, if there's anyone who would help with that or would like to collaborate in the project, that would be awesome. We can talk about that as well on the Discord channel. That would be awesome. But yeah, so far I'm doing everything right now, so but that's good. Okay, so let's see questions. I'm gonna do this as we go. So I was intending to pop out the chat here. All right, so this is one. Maybe we can even make it more. Do you have a vision while learning machine learning? How you wanted to deploy those models? All right, and what is a ML AI learning path you would propose for a beginner like me? All right, let's see. So are you guys okay if I show your names as the people who are asking these questions? If I were to put here like a small thumbnail or something and put the name. Yeah, by Major. Yeah, I'll reply to the question now, and we'll keep going. See you later. Okay, so we got one more here. Okay, here now I'm just gonna answer a question by Sujay Kumarji. I hope I'm pronouncing your name right. What is an ML AI learning path you would propose for a beginner like me? I believe there are many different libraries, frameworks, books, and resources that are directed to people who don't know anything about AI or machine learning in terms of coding. And at least for me, it took a few years to understand the underlying concepts. I think what's good is just read and keep looking at code, keep looking at programs, keep looking at what each algorithm does, and then you'll try to understand bit by bit the different categories there are, what types of algorithms, why were they created, and how they work. And it helps sometimes to go and say, okay, I'm just going to take a look at a glossary of terms. I'm just going to take a look at definitions of things and see what is a model, what is gradient descent, what is an image classifier, what is a segmentation network, all these things. Take a look as well at frameworks, what the different frameworks do and what they're good for. Maybe also read books, right? Books are intended for people who are in computer science, but also have introduction to concepts. And, one thing that really helped me out is watching courses. So watching courses online, there is one that I would recommend that I'm halfway through. That is the Stanford CS231N course. That course goes through convolutional neural networks, but it also covers a lot of other stuff, a lot of computer vision problems and concepts, and also covers later more things, I think, like object detection, segmentation, and at least it talks about the overall concepts. Then there is this hands-on coding tutorial on the fast.ai website. Fast AI is a Python library as well for computer vision and machine learning. But it really helps just going through the examples, I think the TensorFlow tutorials website is really good as well. Some of the resources that I showed before, the ML5.js and P5, well, not P5.js, but TensorFlow.js, looking at those examples and maybe trying to build the small web tabs or web apps with simple things. And one of the things that tries or helps to understand machine learning a bit better is trying to download pre-trained models, so models that already exist, that have something, a behavior that other people train them for, and just trying to feed your own data to them. Just trying to see what they do, the type of data they return, how they work, and read about what complexities the training of those networks had, and what do you have to do to retrain them? Can you do transfer learning on them? So can you start from something that's already done and just try to feed your own images? The purpose of machine learning is to have a model, an algorithm, or an architecture type for a model that lets you train on data, which means you don't have to rewrite any code. So if a model works, it works well for what it does, but also is subject to not work if the data doesn't look like the data it was originally planned for, right? Something like Inception or ResNet are neural networks that have to do with image classification, and they are optimized to work with photography, right? So if you have photos of vector drawings, maybe the accuracy won't be the same. But at the same time, you can get one of those networks and retrain it on your own data. You can also look at interfaces by the Magenta team at Google, that they have done a lot of creative projects. And yeah, I would say the ML5 and the Magenta projects are some of the ones for beginners to understand the underlying concepts. The first thing would be to understand, for a beginner, the high-level concepts. So what machine learning is, the difference with AI and deep learning, reinforcement learning, image classification, object detection. A lot of these terms that are being overused. What does each one mean? How do they differ from the other? And once you do that, you will start realizing, okay, now I can go a bit deeper and maybe get hands-on coding. I don't really know if you know how to code, but if you know how to code, the best way is just to get to the Google tutorials and open the Colab versions and try to just run the Python code and change things here and there and try to start understanding. I'm also learning myself, so this is not something that, Nono is an expert and he doesn't need to learn anything else. This is why I'm doing this project in the first place. So thanks a lot for your question. All right. Hi, everyone. We have another question from Mayur Mystery. And the question says, do you have a vision while learning machine learning about how you wanted to deploy those models in AEC? When I first started learning machine learning, I started playing with Pix2Pix. So that's one of the most well-known generative adversarial networks, or GANs. It got viral because somebody actually did a TensorFlow port that could be used in the browser of the original research PyTorch model that was developed by Philippe Isola. I don't remember the name, Christopher something, who did the port, but what's important to know is what caught my attention in that model was how magical the input-output pairing was. And what made it get to me was that it went viral, was something that was attention calling and people wanted to get to use it. You could open a tab, you could draw with lines and strokes, simple strokes, a cat, and then you would get a texture of that shape as a photography of the cat. And people did monsters, right? People would try to draw a cat, but then when they misdraw it or drew it in a different way that the model had learned it, they would create like a cat with 3, 4, 5, 6 eyes, or like a really big mouth, or like with really, really creepy sensations, right? This model let me start getting to use machine learning without really understanding it. So I was just swapping the data on the sample model with my own data. So I was preparing data sets and generating new programs. So I didn't really know anything about machine learning that much. And I became more a data scientist where I had to gather data and put in a given format. And this would make the program change its behavior. And that was magical, right? I was thinking on the implications on what the end model I wanted to be used for. In this case, in the area of hand sketching, converting a line drawing into textured sketches, like feeling like some sort of watercolor. And that was what that was my thinking in the AEC. It wasn't really AEC, it was more in the creative field. I was thinking more towards how does this type of algorithms play inside of the realm of an artist, a designer, of somebody who is actually trying to come up with something original or different, or at least just having thoughts. And I added it to the realm of online collaboration and collaborative drawing and things like that. So yeah, I wasn't explicitly thinking about the architecture, engineering, and construction industry, but more on how does it help us create something different or more idiosyncratic in a way that, the model, as you can express yourself when you're drawing, how can a machine learning model express itself as well in that process? Thanks a lot for the question. Yeah, thank you, Suje. I think that would be really useful. I think it's a really nice course to watch. All right, so I was muted and I keep doing this. So I want just to take a look here. So the training of this model completed. So go completed, and I'm just gonna compare them. So we have here this took 834. So that's 13 minutes, but let me see which one this is. This is not the one. So 7 minutes, and we actually got, wow, this is really nice. All right. We got charged 3.8 minutes. This is pretty impressive. I'm surprised. So let's see how many epochs we actually took to train this. So we trained for 20 epochs, and this is really fast. So this is 3.8 minutes. So okay, let's actually make the real test. We'll do one more test for this. It's gonna take maybe 8 or 10 minutes to run the entire thing. And I'm also gonna add here to the name the epochs. All right, so we'll just run everything above here, and you just let me know, Sujay, if the sound is back now. All right, and this is 100 epochs. Okay, so we're gonna run everything. We won't attach to this. So we're going to run all, and we'll fire one last job today. So this last job is going to be 100 epochs. So the same here, 100 epochs. And what we're gonna do is now see the log to see with this instance how much time it took to train each of the epochs, right? Before it was taking 3 seconds. I have an analog recorder here that I can switch on and off, and when I manipulate the microphone I switch it off and I keep forgetting. So I should probably leave the bad audio bleeding so I don't mute myself anymore. Okay, so let's see, what do we have here? Okay, so I have this here, so we're gonna see the logs. All right, so we need to do this. I really don't know why this is happening. Okay, so this is low. We have a GPU. We don't really get to see. So we have we have 8 GPUs or 16 GPUs. We have 16 GPUs. I don't know. We have a lot of GPUs here. I don't really know how many there are really. And each epoch is taking, that's not good. Each epoch takes 4 seconds. 14, 17, 4 seconds. This doesn't make any sense to me, but well, whatever. So maybe we can't utilize that much amount of GPU there, and we're just like, I don't know, maybe we have a like faster setup time or something. Yeah, setup here is super fast. So we start training in like 10 seconds. So it might be that this machine is actually a lot better also in terms of CPU. Yeah, okay, so we'll see. We just want to compare this and that one just to see on 100 epochs how much time it takes to train both of them. All right. Okay, I'm gonna take another quick break and then we'll do a bit of a final round. So we're gonna do something a bit more interactive, something that is gonna be a bit more visual, and hopefully that's what we're gonna be starting to engage more and more over the next days. So we're gonna start taking a look at things like P5 and glitch and visual, just trying to build an application to see and use these machine learning models a bit more visually. Okay, I'll be All right, so we got sound, we're back, and everything should be good. So, so we're, this is a longer live stream. So we've been going for 3 hours right now, and I just want to keep going for a bit more because I had time today, and I don't know if this training job has finished, but one thing is that we have tried the AWS SageMaker to train models in the cloud, and we have this notebook here that we can clean up a bit. So this is actually some stuff that I did here to create the name of the model. So we can maybe just clean up a bit before we leave this notebook dirty for another day. It's a good practice. So here we have setup, SageMaker, permissions. Here we do build, so parameterize training jobs name. Maybe I'll move myself again to the right so you can see what I'm writing. This has to be put as markdown, and parameterize, yes, datetime, Docker images, epochs, instance type. Probably want to leave it to test with this that is a bit cheaper. Image URI and GPU. All right. Let's just leave this here. Okay, maybe we can put this here. So this is really good practice, cleaning up before you go, otherwise you won't know what you did. So the parameterized name is here, so we can now just put this there. Epochs. Or maybe we just leave it like this, otherwise it's gonna be hard to understand. And that. All right. So okay, yeah, I guess we can leave this like this. So parameter configuration, build our estimator, and then start training job. So here, if we put the wait false, so if we put wait false, we're not going to wait for the execution. True. Makes no wait and logs output in real time. All right, so this is done. We have the notebook, and I think this is fairly okay. All right, let me see. So I can actually put this on somewhere. Don't know where I can put this, but maybe let's make a new repo on GitHub. So repo, so let's say ASP, and then we'll go here. So GitHub. Let's open source that code so we have it on a place that anyone can access. So new repo. How do we call this? AWS training custom workflow, no, custom TensorFlow model SageMaker. Maybe public readme. TensorFlow sample notebook to train a custom TensorFlow model in AWS SageMaker. All right, so now that we have this, we can create the repo. For those of you who are not familiar with Git, I'm gonna do some magic here. I'm just going to clone this. So now we have this remote folder on my machine. We can edit that. Okay, so now I have that repo open on my machine, so it has the MIT license. Oops. And the README. We're just gonna download these assets from the web, so train SageMaker. Let's just put train, well, train SageMaker, hope, and fashion memnist. So we are going to download that one, and download that one, keep. We just do git add all, git commit. What's our commit message? Add training script and notebook. Right, now we push. And now that should be here. And what's good is, I have now these two files there. They're open source. This is a lot better to browse the code. So I can browse the Python code here. This is probably what I should have done initially. And I can browse the notebook. We can browse the notebook, and we could even see the logs here if they were there. We can clean the output of the notebook if we want, so that we don't introduce weird changes just for running the notebook. So we clean that up, we save, we can download again, and I'm gonna replace. I have a helper method here to do everything at once. So I can put here clear cell outputs. And now this should be up to date. All right, so what I'm gonna do now is that I'm going to yeah, so I'm just gonna put the link to this on the Discord channel. So I'll put it here. So links for live 8, and I'll just write this right here. And I believe I have this here. You know, maybe I could do some stuff here. Okay. Preview. Okay, so we have that there. Maybe it would be a good practice to do this every week. All right. All right. I would like to say hi if there's anyone new that has connected. Feel free to write on the chat and let us know where you're connecting from. Okay, so my session has expired in AWS. I'm just going to log in once again. And just gotta do a few things here. Wait for it. Right, almost there. Boom. Okay, so we're back at the training job. So this one took 13 minutes. All right, so that seems like a sad story because we've trained with this P3 2x large GPU and then this one with P3 16x large GPU. But this might mean that this job that we did, well, actually, before I start talking more, let's just take a look at this one. So let's just take a look at whether what I'm saying is true. So for the algorithm with the 2x large, that is the one on the left, we've been charged for 585 seconds. And the one on the right, just barely like 7 seconds less. And that actually doesn't make any sense because this is a lot more expensive and this is taking the same amount of time for training that. So summary story, I would say the 16x large is not something we're taking advantage of because we're not properly using the 16 or whatever GPUs this has. So that's what I would get out of it. All right. So let's see. So for the price, unless we do some optimization for the price, you know, we could stick with this if we don't, you know, we can, but we could go with this if we want to save time. If the algorithms are bigger, are like slower to train, then there would be a bigger difference. All right, so I promised we're gonna move away from this. Let's close these things. Let's not forget to close my notebook. So I have to go here to close the notebooks that are in service. So I just go here, click on there, and then clicking here to stop the notebook. This takes a few seconds, but I don't think I'm being charged while this is being stopped. And the other thing is that we have our training output here. So we have our training output in this bucket, right? So we've been getting these things here, and we have the output for each of the models. I think they will all be the same because we've trained with the same epochs except for one. So we can go here and download the model, and now we could do something with it. We could do something really quick. We could just unzip that model and see that it's a normal TensorFlow model, and we can actually use this locally. So now we're going to close AWS. I'm going to minimize this, and what I want to do is, so we have the path to this model. So let's say fashion MNIST model, and we're going to copy the path. I'm going to go to the terminal. So I'm going to simply open a Jupyter lab. So let's say make there live 8 and do live 8, and then we're gonna do conda activate tf 2.3.1 Jupyter lab. So I have a Python environment that has TensorFlow 2.3.1, and we are now, you know, now we have this here and it's available for us. This is locally, so I'm just using my CPU and my computer. And as you've seen, I've created, for the tutorial before, I've created many kernels that I need to delete. But, you know, we have this one here. We can do this helper command that I have here to make sure that everything's working. We can see the CPU devices that are available for us. We can see the TensorFlow version, and I'm happy that this was fairly fast, right? So what we can do now, so we have our path. So let's say model dir. This is our model directory. And with TensorFlow, we can directly say, okay, our model is our TF, well, we can do TF Keras models, load model, and we can just specify the model directory. And then we can ask for the model summary. That's fairly easy. So we've recovered what we had last week, and it's a model that we save to our local machine. And now we can create an input value. So let's just say that X is TF random uniform, and it's going to be shaped 28 by 28. That's what the model wants. So we get here that, you know, we have a tensor shape 28 by 28 pixels, and that's what it is. It's 28 by 28, just numbers with one, what is it, one channel. We do have here the let me see. So what we have here is floating numbers, really small floating numbers, but we would like to do is like integers, right? So something that we can actually visualize as integer values. D type. Int 32. So TF. So D type, TF, D types, int 32. Doesn't work. Max val. So we do min val equals 0, max val equals 255, and that's it. We get our array of a lot of numbers. And what we're gonna do is, well, let's just visualize a bit of it. And we can actually do import matplotlib pyplot as plt. We can call here plt image show, but our image that we can visualize for that data type, we actually cannot just call this, right? We cannot just visualize X. Well, actually we can. All right, why didn't this work before? I don't remember right now. Maybe because of the D types. So this is actually the image that we're generating, that again, to make it a bit more truthful, this is what we're actually generating. So it's like a grayscale image, and we can do our model. So let's see if we can just predict, right? So Y would be model predict X, and then we'll get Y. Let's see. All right, so this is the error I always get. It's just telling me that it's not a batch. It's non-28. So I just need to make it a batch. So I could, one way you could do that probably is this, not that way. So tf expand dems of x axis 0. All right, and then we get our output. And our output is just a set of probabilities, and if we do np argmax, that we can actually see it there. Import numpy as np. It's 5, so it's telling us that it's 5. We have the logits function, so we are actually, I think we were using a softmax here, so instead of the logits we're actually getting, I think, probabilities. And what we can do now is go to the internet and say, okay, boots, and let's just get this image, and save it to our folder. So for instance here, boot, and we'll do so let me see if I can load. So from pl import image. All right, so image open. So my image is image open boot JPEG. What is it? Boot.jpg. So we can do here open this image, I think, and then return it. All right, so we do here resize to 28 by 28. Yeah, okay, so that's our boot. And convert to grayscale. Can I do that? I'm not sure, because this is all right. So this has 3 channels. So we do input. This has 3 channels. Okay, so peel to grayscale. TensorFlow image RGB to grayscale. I think there is, okay, RGB to grayscale. All right. So TF image RGB to grayscale input, and then input shape again. All right, so now we got it, and we can actually do plot image show. This won't work, maybe. Yeah, so now we gotta do the pre-processing image array to image input. All right. Okay, so we have that, and I think we just need to invert it. So we just need to do something like this. Yes, and that would be our input. So our input is going to be here, and that's going to be our input boot. And just to make this a bit better, so as an experience, let's actually pull out the let's pull out the list of tags that we have written, and that way when we get the argmax, when we actually get the what class that object is, it will tell us what it is. It won't just say a number. All right, so we close things here and we get the class names. We can put this above. Right, we run that cell, and now let me just open here this stuff. Okay, so now what we're gonna do is pass this through the network. So here, for instance, before argmax 5, this was actually sandal, right? I mean, that was just a random image, but that's what the model is telling us. So output might be model predict with our input, and now we'll do np argmax of output, and then we'll do class names, and this is our class name, and we'll do this looks like a, to me, format, and then we'll say here class name. All right, so we'll call it so shape for input tensor flatten is called with none. Okay, so again, we're not expanding the dimensions, expand them, axis 0, and that's it. Invalid syntax, class name, probably there. List object is not callable. It's too late here. Too many errors. All right, so let's see if this works. Looks like a sandal to me. Okay, again, it's a sandal. That's a bit weird. Okay, so I'm not sure if we've trained this model properly. Let's just see, because if this is actually returning the same than before, maybe it actually is not training properly. Yeah, so it's returning exactly the same than before. So let's actually, because I don't really know if the training job was working properly, we're just going to run our model here, and we'll save this model and download it and try with that script. With this, you know, just to recap a bit, what I'm trying to show is that you can actually train a model somewhere in a notebook, on SageMaker, on your machine, on Google Colab, and then you can save it. And then when you save that model, you can get that file and then upload it anywhere or using your machine, even on your mobile phone, and then load that model and then predict with it, right? That's the purpose of AI and machine learning, right? So here, what we're doing is that we're training. So we're training a model. So we're calling model fit. This is, if you want to see more, you can go to live stream number 7. And we are training. So we're training, I think this is exactly the same model or the other one, not sure. Hommel, hands-on machine learning. So we're gonna wait for these two models to finish, and then we'll save them, and then we will use them. So let's actually write the code here that we need to save this. Okay, so the code is, and you know, for those of you who prefer dark mode, Corgi mode, what is that? Don't remember where dark mode is. All right, so what we're seeing now, so this is training above, and what I'm gonna do is I'm gonna save the variable called SaveModel hands-on machine learning, right? So we're gonna do TF Keras models, say model. I think this is the syntax, but we could also call model homo save, and then we'll just say fashion no, yeah, well, let's, yeah, homo, let's just try to do that, and that will run after we finish. Right, let's see how long it's left on the training. So it seems like one model probably already finished. Yeah, the normal model finished, and then the second model is training. So you see, this actually is better, right? We're seeing the output, we're training, and we're gonna save the model, and then we can download it, and we didn't really have to you know, to spin up other machine or do anything, but our notebook is frozen. All right, so now everything's gonna run really quickly, and done. Cool. So now we probably have the model. Right. Cool. So now we're gonna download this. Can we download that? Not really. Let's zip it. So we're going to zip. We're gonna go into the folder. So fashion mnist ml. We're going to then zip everything here into fashion mnist homo zip and everything that's in this directory. All right. Okay, usually, yeah, I'll redo this command. Usually what I like to do is to put the file on the parent directory, and there is a script that you can use also to get the folder name automatically. So then we have this zip file here, we download it, and this is our model. So this is probably going to be a model that performs better. Hopefully it works with what I'm doing, and we just have to do this and change the path. All right, so now we can go back to our Jupyter lab. It's too bright now. And we just changed the name of the model folder. So the path. And we execute everything. Well, that's changed that list. I don't know. Okay, so yeah, that looks like an ankle boot to me. Okay, that makes more sense. So maybe this wasn't wrong, but the data set, I don't really know if that was working. Okay, can we open, well, let's download more images. Shirt. So we now go and download this image, put it here. And we're now gonna put this name here. We'll run the whole thing. It looks like a bag to me. Okay. Yeah, probably the data set doesn't match that much. But yeah, I mean, it's working. It's not a great model, but if we were to get something that fits a bit more the proportion, I think this maybe fits a bit better the proportions. Shirt 2. Shirt 2. Run all cells. This looks like a shirt to me. Haha. Nice. Okay, yeah, so important thing to learn here. We got 2 out of 3 right here. And what's happened is that this shirt looks a lot like the shirts on the training set. The format and the places where the shirt is, if we make this image, this is vertical, probably, and I'm gonna try like image 1 or something, shirt 1. I don't really know if I would be right, but I think if I cut this more on a square proportion and I put here shirt 1, that might actually make it classify as a shirt. Oh, still like looks like a bag. Yeah, and yeah, things are weird, but let's try one more thing. Just really one more thing to see if we can make it a bit better. So maybe TensorFlow increase contrast. No, peel increase contrast. Not going to explore too much stuff right now. So we'll just increase a bit. We'll just make the background lighter so it's actually white. All right. So if we run this again, can we fool it? Yeah. Okay. This looks like a t-shirt top to me. Yeah. So you gotta understand the nature of the dataset. So the dataset has a really clean white background. And if you put an image that is gray in the background, then that might mess up a lot with it. But if you input it with data that looks really similar to what it was trained on, the results will be a lot better. Okay, so we have done that. So this is like a notebook that I'm gonna also save. Let's actually do how do we all right, let's see. So we're running out of time again. So I'm gonna go to my list. It seems like we've done all of this. We haven't covered the Keras applications. We can take a look at that. And I would like to retake a bit some of the things that we started doing with Electron a while ago. So we're going to have here we're gonna have here a new collab notebook. All right, so this is live 8 and this is Keras applications. So Keras by itself, so if we go to Keras.io API/applications. We can get from TensorFlow, we can get the Keras applications ResNet, import ResNet50. There's a lot of stuff we can do here. And as you can see, when we instantiate it, we can load the weights, and we can predict, and we can do many things. So let's just use this code and write it. So I'm gonna put this here and see what we're gonna be writing. So we don't really need to do this all exactly. So image preprocessing, we can just write the code from, like, what happens here is that this is a way of working where you, instead of rewriting everything that's in here, you import parts of those models, but you could rewrite directly things like tf.keras.preprocessing, like I've been doing before, right? So we could do here just import TensorFlow as TF. That's usually what I do, and maybe import NumPy as MP. Right? Those are the normal inputs that I usually do. And from there you can go and say, okay, my model, I could say my model is going to be TF Keras applications ResNet. You see here ResNet50, ResNet50, and then you can say weights ImageNet. What does this mean? So if we don't put this here, so we just load the model, we can make a summary. We just download that model, ResNet weights TF dim operation TF kernel, whatever that means. So we can print a model summary, and we'll get all the layers of ResNet50 listed. If we add the weights ImageNet, we're specifying which pre-trained weights, what weights or what data set, the weights of the model, right? When it was trained with ImageNet, which allows us to classify normal, like day-to-day images with it. So this is a model summary, so we're just gonna take this out. And now that we have that, what you can see is that after you load the model, all you have to do is load an image as we did before and predict with it. And then there is a helper function to decode the predictions from the Keras model that shows the predictions in a way so we don't have to format the resulting dictionary. So okay, let's go here and import. So I like that ResNet50 pre-processing, right? Which in some way we could do here. We could actually just probably build it here. Well, let's actually just see it. So we will do load an image. Let's download an image from the internet. So let's say we do this one. And we have here African, so input name, let's say is African leopard.jpg. So one thing that is nice about Keras is that it allows us to, it has helper functions, so we don't have to worry about what I did before of loading the image and formatting it in the right way and making sure it has the right channels and all that stuff. So you can specify directly, this would be image, that is tf.keras.image.loadImage, the image path, and then the target size, right? So let's say we just do the same, so image path, right? So we got the image path, and then we do here And if I recap a bit what we're doing right now, let's actually just make this like a little video when we have it properly. Yeah, okay. So we have here, and we can do tf keras image load image, right? Load image path, and then the target size. So target size is 224 by 224. This is because the input size of the model that we're using, if we print the model summary, maybe we can see it there. So we go up to the first layer, input layer, it gets a 224 by 224 image. So this is height, this is width, and this is channels, RGB, right? Okay, model has not image. TF Keras, maybe pre-processing. All right, so we've loaded the image, and then it's also getting resized. So our image is going to be that one. And what they're doing is that they're converting it to an array, and they're expanding the dimensions of axis 0 and then doing the pre-processing, right? So we'll just do tf keras pre-processing image, and you see where this can get verbose, right? Image to array, and then we do image, and then you get something, and then we do, that's not an image anymore. Yeah, that's actually not an image anymore. This is our input, and then we can use MP, or we can use directly TensorFlow. So we can do X on axis 0, and then what they do is that they pre-process the input. So let's see what this does. So what we get here, we get a 224. So it's a batch of 224 by 224 images and 3 channels RGB, and it goes from 0 to 255. And when we do this pre-process input, that actually comes from ResNet, so we'll do it here. So we'll do TF Keras applications ResNet50 pre-process input, and then pass that one. Let's see what we get. You see, we get something a bit different. So we get something that, what do we get here? Not really sure what happens, but okay, so that's it. And then we can get the predictions. So predictions equal model.predict on our input, and then if we print our predictions, we just get these that are probably the logits or the probabilities for all the existing classes, and then we use the decode predictions function. Decoded predictions, we do TF Keras applications ResNet50 decode predictions, and then we put our predictions there. All right, so that seems like it worked. We loaded, yeah, we got the image nest class index, so that's like just a list with index mapping to a class name. For instance, class 170 is Irish Wolfhound. And what we can do now is we can decode, well, they decode with top 3. So we'll do the same, top 3. Top 3. And now we just print it. and we get 0 for the first item, because right now, if we print here the coded predictions shape, actually can get that, it's an array or something. All right, so let's just remove this cell and just run it. Okay, it's a leopard, right? So we didn't really train any models here. So we just use one that is off the shelf. Cheetah is the second one, and third one is Jaguar. And for the leopard, it's a 65% accuracy. So, you know, I would say it's a fairly reasonable, like really no effort to get a classifier working. And you can see all this code here, all these really long lines are because I didn't import the helper functions as they do. So here you can say, for example, import TensorFlow.Keras.preprocessing.image as image, right? And that way you can cut these things directly and use the image namespace directly, and then you can do import TensorFlow Keras.applications.ResNet50 as so they do from, right? So from these ones as ResNet50, and then they do preprocess input and decode predictions. All right, so after we do this, right, we don't need to put this here, and we don't need to put this here. So preprocess input, and then we don't need to put this here, and that's it. So if we go and run everything, so we can run all. All right, what's happened? Can import name image from okay, does this work? Yes. All right, so now let's just try, now that we have this set up, let's just try with another image. So this would be like bird or something. All right, so we'll get this one, we get this here, and now we change this to blue bird, and then we just run everything again. And our predictions now are J, indigo bunting, bulbul. So I didn't even know what that was, but J bird. Yes, looks like it. All right, yeah, so this is pretty straightforward, but really powerful. And let's see if this is available in Keras and TensorFlow.js. So we can call ResNet TensorFlow.js applications Keras model TF Keras. This is core TF Keras loading ResNet50 TensorFlow.js. Yeah, so this would be useful. So we want to, maybe we have a like a Keras model and we want to load it in input format Keras, import a TensorFlow model. Yeah, so what we have is a SavedModel, so we can, if we don't have it, so let's say Anaconda environment, what I'm gonna do is I'm gonna do Conda create name TensorFlow.js, Python 3.8 PyKernel. Yes. So for next week, probably, we could see live 9. So let's see, we say TensorFlow.js. We can see this. We're gonna do this probably now, but we want to do as well maybe something like what is this? Electron interactive app application. All right. Okay, so this is live 9. We're gonna now continue here. TensorFlow.js, so pip install TensorFlow.js. So when you install TensorFlow.js on your environment or your Python environment, it also installs this TensorFlow.js _ converter. This is a tool that helps you convert models from, like a Keras model or a SavedModel into something that can be run on the browser with Node.js or in the browser directly with TensorFlow.js. So this is installed in there. We can start building our commands. So if we do conda-activate tf.js, the command that we're gonna have to build is something like this. So we'll go to the directory where our model lives. So we'll do live 8, and then we have, this directory has it contains the model, but as a SavedModel. So it's not Keras and it's not TensorFlow.js. So we can load it with TensorFlow Core, but we cannot load it with TensorFlow.js. So what we would do here is we'll say, okay, TensorFlow.js converter. Can we get the version number? I don't know. Maybe. Is that installed? It's installed. I don't really know if this works, but yeah, let's just close this here. So okay, so we do TensorFlow.js converter, and then we do the input format is tf SavedModel. I'll put no name cell model tags. Yeah, and so we have here the fashion mnet SOML, and then we'll do like web model. All right, so this should be now, if this works, I don't know, it might fail something, but if this works, we should see this just converting. Okay, so we now have this model.json that is the base of our model, and we can go to our folder. So we can go to live 8, and there you go. So this web model directory actually contains the binary information in what's called a shard, because this model is small, we only have one, but there is like a limit where they start splitting depending on the size. And then this JSON file. So if we open the JSON file, it will contain some information about the model, of its type of inputs, the layers it has, the sizes. So for instance, you can see here it's 28 by 28, and it allows batches to get imported. And I think there is this, let me pause for a second. All right, so we're gonna cut here. This is something we'll see next week. So we'll convert our model, which we've done, but we'll convert the model, convert another models, and we're going to use them in an application. So it's going to be a web app. We'll try to run it on Google Chrome on a tab, also in an Electron application, hopefully. So I'll write this down here so we know. And run converted SavedModel in Google Chrome and Electron, and then build some interactive app drawing or like drag and drop image. All right, so I think we'll leave it here. So maybe just we'll just try to see if our neural network, the ResNet neural network, can recognize what this is. And I just want to wish you happy Thanksgiving if you're celebrating with family or with your friends or with whoever you are celebrating. And let's see how this works. All right, so runtime, run all, and now we're just gonna see what this says. Hen, black rose, European gallinule. All right, I'm not sure, but that doesn't look like a hen to me. Clearly a turkey. All right, so without further ado, I'm just gonna open here. I don't know if there will be anyone who's waited with us for so long, but I'll just open the slides. Okay, just give me 1 second. Can you hear me now? Is the video lagging still, or is it sounding well? All right. Okay, yeah, so thanks so much for everyone who watched the video today. This was a really long live stream. I hope that you got something out of it. And I don't really know what's going on here, what's lagging right now, but let me just close everything. All right, I'll just try this and we'll stop. It seems like 4 hours of live stream was a bit too much for my machine. So yeah, this was part of the machine learning series. If you like the video, please go ahead and like it, because this informs me that I have to continue doing this type of content. Share it with your friends if you found it useful. Maybe today was a bit too technical, as Sujay said, but we're just trying to keep on learning, myself included. And go and subscribe if you want to get notified of future live stream, future video uploads, and any other news. Join the community as others have already if you want to chat with us and want to learn more about what we're doing, what projects we're working on, maybe share your own projects, and also tell us what you're working on. All right, so yeah, this was it for today. Thanks so much for watching, and we'll see you next time. So yeah, I'll cut off now. Thanks, Sajay, for being there, and for the others who have connected today and asked questions. I will trim parts of today's video and upload it to the channel. We can continue talking online to seeing how we can collaborate and how you guys can help with the project and how we can all contribute to learning more machine learning and doing more fun things. So once again, it was Nono. Thanks so much, and I'll see you next week.